Bismillahirrahmanirrahim. NumPy mathematical and statistical functions. NumPy offers hundreds of functions for performing different operations using NumPy array. In today's lecture, we will discuss some basic NumPy mathematical and statistical functions. So let's say we start with the sum function, which is used to add elements of array over a given axis. Normally, in most of the functions, here we will use two arguments. The first argument specifies the array on which we want to perform operation, and the second is axis. Axis 0 mean columns. If we want to perform some operation on columns, for example, to get the sum of each column, so we will specify x is equal to 0. If it is required to get the sum of each row, then axis will be equal to 1. So now here we perform some operations using the Python. So it is a two-dimensional array. Now we are here applying the sum function on the data. Data is the array and axis is 0. We want to get the sum of each column. So 24, 39 and 40, because there are 3 columns in this array. Similarly, if we change the axis equal to 1, so it will return the sum for each row in the array. So first of all, we will import the NumPy library. Now let we apply this function, sum function, on one-dimensional array. So here is a one-dimensional array x. Now we want to apply the function sum on this array, np.sum. So it will return the sum of all values in the above array. So 110 is the total of the above array. If we have a two-dimensional array, so we can also apply the same function on the two-dimensional array. So here is an array with 4 rows and 3 columns. Now let we apply the same function on this two-dimensional array. So np.sum data. So it will return the sum of all values in the above array. If it is required to get the sum for each column, so we can specify the axis. Axis is 0. 0 mean to perform operation along column. So it will return the sum of each columns in the given array. Similarly, if x is equal to 1, so it will return the sum for each rows. So there is another statistical function mean. Mean to calculate the arithmetic mean of the given data. So it will return, if we are not mentioning the axis, so it will return the mean for the entire data. It will perform the operation over the flattened array without regarding the rows and columns. If it is required to get the mean for each column, so just specify the axis. So it will return the mean for each column. In the same way, we can use x is equal to 1 to get the mean for each row. Another statistical measure is standard deviation, np.std. Standard deviation basically measure the spreadness in the data with respect to the arithmetic mean. The more spread the data, the larger the standard deviation. So here it will return the standard deviation for the above data, and this is basically sample population mean. If we want to calculate for the sample mean, so we will change the delta degree of freedom to 1, because by default its value is 0. So now it will return the standard deviation per sample. Similarly, we can use the excess argument to get the standard deviation for each row or for each column. So it will return, in this case it will return the standard deviation for each column. A variance can be calculated using the variance, and here is data. Similarly, excess is equal to 1, for example. So it will return the variance for each row in the given data. So when standard deviation has a small value, then it means that there is less spreadness in the data with respect to the mean, and if it has a large value, so it means there is more spreadness in the data. Similarly, we can find the maximum and minimum value in the data. np.max data, so it will return the maximum value in the data, and if it is required to get the maximum value for the each column, so we can specify the excess in this way. Similarly, if it is required to get the minimum value in the each column, so we can use the minimum function, mathematical function. Now to get the square root, square root returns the square root for each element in the array. Its result is element wise. Let's say we have a data, so it will return the square root for each value in the above data. So there are 4 rows and 3 columns, so it is the square root for each value in the given data. To get the cumulative sum of the data, let's say we have a array np.array. So cumulative sum is basically a sequence of partial sums of a given sequence, which is also called running total, in which each value is headed from the sequence to the sum of its predecessor. So let's say we np dot cumulative sum, and then we use the array as another argument, so it will return the cumulative sum like this one, 3, and then 3 is added to the predecessor, and it will be equal to 6, and so on. So in this way we can use the median. Median basically is the middle value of the data, which separate the high of from the lower of. So it is also a most widely statistical measures. So np dot median, median and data, so it will return from the above array median, and if it is required to get the median for each column, so we can specify the excess like this one. product, so np dot prod a, so it will return the product 900. So basically it returns the product of array elements over a given axis and actually multiplies each element. So if we want to get on some axis like 0, so because actually this is the one-dimensional array, so mentioning axis has no meaning in this case. But if we use the data, then we can get the product for each column, like this one. Similarly, we can use the different trigonometric function sine, cos, or np sine and data. So it will return the sine value for each value in the data in the NumPy arrays. So we can use the different functions for different tasks. So let's say sometimes we want to calculate the weighted average in which data is given in the with values, and also weights are also given, like this one. For example, we have x. This is the NumPy array which contain the student marks, test marks, let's say of 4 students for example, and there is weight, number of students having a marks. So let's say there are 5 students having 2 marks, 3 and 5, and these are the weights for the above array. Now for the weighted array, normally we multiply the weight with the values. So here is the wx. So we can perform this operation in NumPy array with just to multiply the both array. So w and x. So we will get the weight x. Now to calculate the summation, sum of wx. So just use the sum function np dot sum and use wx as an argument. So in this case, now to calculate the mean, for example, m is equal to, so we can write swx divided by np dot sum weight. So in this way we can write, we can print the values for the each equation. For example, wx, then swx and mean m. So this is the first show the wx array, then it is the sum total of summation of the wx, and last it is the arithmetic mean. So in this way we can use the NumPy array, and we can apply different mathematical and statistical operation on the NumPy array. So okay, thank you.